This is Algebra 1, Term 4, Lesson 13, Polynomials. We'll begin with the Desmos activity, then we'll do some vocabulary work in graspable math, and we'll finish it up with a Mathagon exploration and a little something extra for the kids' portfolios. So let's start in Desmos. The Desmos activity is entitled Polynomials. They will be learning the different types of polynomials and some of the vocabulary associated with them, and also they will be doing operations with polynomials. There are 20 screens, quite a few, so this will take the bulk of your time. On this one, they're given examples of polynomials and not polynomials. What they're supposed to do is differentiate between the two. What do you notice about the ones that are polynomials versus the ones that are not? They may not notice everything right away, so the more you can pull from the kids here, the better. So what I like to do on problems like this is look for good answers and write them up on the board as I see them, and then talk about a formal definition after we've completed the first two screens. What do you notice about the terms of the polynomial? 1, 2, 3, 2. What is a term? Again, we don't have a lot of formal vocabulary, but what we'll do as the kids put things is we will develop more formal vocabulary. Some of these kids may already know monomial, binomial, trinomial because we have used those terms and we have learned them in a previous lesson. So celebrate the kids that remember those terms and use them. On this one, you're asked to wonder about the number of terms of a polynomial. Now, the one that's unexpected is this third one. They'll see that plus sign and they'll automatically say 2 terms, but let them think about that for a while. Why might that just be 1 term? I do have some sample responses, so be sure to check those if you're not sure of how to direct your kids. And then finally, explain how to determine the number of terms in a polynomial. All right, then they are to give an example of a polynomial you think might be difficult to determine the number of terms. So maybe one like the one that was in the table that was a little bit difficult to understand. They could come up with something similar. All right, this is the degree of a polynomial. Again, they are discovering these rules. You will tell them at the end, but don't tell them up front. Let them see if they can come up with a reason that the first polynomial in this table is degree 3, and the second is degree 2, and the third is degree 1. The degrees, when you have mixed variables, has been left out of this list. If you want to include that, you could maybe add something extra to this slide, but I didn't include it because in Algebra 1 we rarely have mixed variable polynomials, so I did not include that. And this one, is there anything you wonder about the degree? Explain how to find the degree. Give an example of a polynomial you think might be puzzling to figure out the degree. And in this one, I did include a little bit about the polynomials with multiple variables, but I sort of doubt they're going to come up with one like that. In this screen, they're going to sort these by monomial, binomial, and trinomial. We have done one like this earlier in the course, so this is basically a refresher. On this one, they're sorting by degree 0, degree 1, and degree 2. Degree 0 is when there is no variable. It's only a constant. If they don't already know that, they probably will figure it out here because the only ones they could put here would be the degree 0. And then on this one, simplify this polynomial expression. What is the degree of the resulting polynomial? So they're practicing a little bit of simplification, and here you'll probably need to discuss adding like terms. My students came to me already knowing how to simplify this type of expression, so I did not spend a lot of time on it. But if you're discovering they need time on it, then go ahead and spend the time on it. I do encourage them to use the graphing calculator to put this expression, all of it, in one row, and then their simplified version in the next row, and they're comparing the graphs of the two functions, which should be the same. If this sum does not produce the same graph as the simplified version in here, it's definitely incorrect, and they need to find their mistake. I do recommend that all the way through this activity in the teacher moves. Same here, they would simplify this expression, and then when they get to the explain part, they're going to tell me the degree of the polynomial. Now we're going to look at polynomial functions. So we have the function f of x and the function g of x. You could talk about linear quadratic. How do you know f of x is quadratic? How do you know g of x is linear? So you could talk about that. We are getting deep into that with the graspable math activities. If you don't want to take the time here to work on that, then you can definitely work on that when you get to the graspable math activity. They will add f of x and g of x and write in standard form. And if they don't know what standard form is, that's standard form. And then on this screen, they're actually going to look at all three. So the first one's a quadratic. There's your linear. When you add the linear and the quadratic, you get another quadratic. And then they're going to type the expression that they have for their answer here. And this should show them the same result as this. So if they haven't messed it up, this is a way of checking their answer. Here they're going to take f of x and g of x, and now they're going to subtract the two polynomials. They're going to write the answer in standard form, and then the same here. They'll graph f of x, they'll graph g of x, and then they'll graph the difference in the two here. And then they'll put their simplified expression here, and it should match the same graph that was there. Now we're going back to the box model, so we're going to write the product of two binomials using the box method, and the product will be a trinomial in this case. And then they'll do the same thing here. J and K were the two binomials. J of x times K of x is the product of the two binomials, which was a quadratic, and then they should have the same here. Okay, finally we've got just the box. Multiply the two binomials, fill in the model, write the product as a trinomial in standard form. How else can you classify this product? So, what type of function is it? What degree is it? So, have them talk about those things. We're using those terms a lot. That's kind of the whole point of the lesson, is not just to actually practice adding, subtracting, multiplying polynomials, but also to use the vocabulary with polynomials. Okay, we've never done one like this, but now we have a binomial times a trinomial. It's pretty much the same as multiplying two binomials. They just multiply like a multiplication table and then take what's inside and simplify it and put it here. They should end up with 4 terms. And we don't have a special name for that. Some students may wonder about that. So you could talk to them about, we name the monomial, the binomial, and the trinomial. But everything after the trinomial, if it's 4 terms, 5 terms, or 6 terms, we just call all of those polynomials. And then we'll finish up with this one. This one's kind of all mixed up. They're looking for the missing pieces. Hopefully by just knowing their multiplication and how a multiplication table works, they will be able to figure out the missing parts. Once they've done that, they'll write their factors for answer 1. The factors are what's on the side of this box. They will classify the factors. Are they both the same? I don't think so. Different classifications, and there's more than one way to classify them. So you could classify them by degree. You could classify them by the number of terms. What is the product? How do you classify the product? The product's inside the box, so when they write their product, they should write it in standard form, and that means simplified as much as possible in descending order by degree. And then they'll finally classify their product. This is the one they probably won't be able to classify much because we don't have a lot of names for this one, but they could at least classify it by degree. And after they do their graspable math activity, they'll have another answer they could add to the number 4 if you want to come back. All right, let's move on to our graspable math activity. The graspable math activity it's pretty long, but it's also pretty quick. If they know their definitions already before they get started, they're going to fly through this. They may take a little longer on some of these new ones because cubic is in here. The first screen, you may decide to make a copy of this and delete this because we've already kind of gone through all that. It does take a while to get through this video, but this just goes through all the different terminology: constant, linear, quadratic, cubic, monomial, binomial, trinomial. So if they don't know those terminologies, they will definitely need to watch this video. If you're pretty confident that they do know what those mean, then they can just continue through the activity. A lot of this is multiple choice. Select the terms that classify a polynomial by the number of terms. And then they're going to pick, I think, 3 of these. And then multiple choice, select each of the terms that classify a polynomial by the degree. And then the rest of these, or almost all of these, are hotspots or multiple choice. So they're going to drag the hotspot to this into this diagram and choose all of the linear polynomials that are not degree 0. We give degree 0 their own special classification of constant. So we're going to stick with linear degree 1 polynomials. So they will only use the degree 1 polynomials here, and then they'll mark them, and then they'll continue. If they get them right, it's going to turn green, so they'll know if it's right, and if it's not right, they need to correct it, so they can change their answer and do that. And then after they've chosen their hotspot, how do you recognize a linear polynomial? So which of these help you know that? And then hotspot, mark all the cubic polynomials. This is the one word we did not have defined already, so this is what the video would need. You would need it for, unless you just want to show them that yourself, and then they can skip their video. More of this, it's all the same. I'm not going to go through all of it. It's 23 of these, so it's kind of lengthy and it is repetitive, but it is just going through every type, and you only go through them, I think, maybe once, and then at the end you combine them. So when you get to 19, it's asking mark the quadratic trinomial. So it needs to be both a quadratic and a trinomial. And then here they're going to mark the cubic binomial. And then they're going to mark the linear monomial. It's not a constant though. It's just a linear monomial. And that's it. So once they're finished with that task, and it should go pretty quickly, we're going to move back to slides. Now this next piece has nothing to do with polynomials. I'm basically giving them something fun to do because this is one of those topics that bores a lot of kids. They are just like, don't want to talk about polynomials. Like, what in the world? Why do I need to know this? I try to go through topics like this as quickly as possible. It's kind of like rip the Band-Aid off in a hurry so we can do something fun. But I do try to break it up. So if you're doing this over a period of 2 days, you might do the Desmos activity and then maybe come do this applications exploration, and then you can go back maybe the next day and then do something fun after that. Break it up, make it as, you know how kids are. They don't want to do some of this most drudgery, and I agree, learning vocabulary is not the most fun. But in this case, this should be fun because they're going to do an exploration, and all they have to do is click on this link, and it's going to take them out to Mathagon, and look at all these. So what I want them to do is pick one, and there's so many to pick from. And they can read through several before they pick one. But they're going to pick on one of these, and they're going to open it up. And these all talk about mathematics in the real world. So maybe they care about satellite navigation. So they can come in here and read about it, and there's actually links out to more articles. They are welcome to go there too. I asked them to take a screenshot of the one that they chose, so they could take the screenshot out here if they want, or they could take a screenshot when they get in here. Building bridges is fun. And this is a bridge, and then they can click here and here to go out and get more information about building bridges. And then they'll just talk about one thing that they learned, and they'll put it on their slide. Pretty simple, but just a break from the ordinary mathematics, and hopefully it gets them back in a good space in their head so they can move along and do some more work. One more thing in slides, so let's take a look. The last slide is simply create a polynomial. So they can go into Desmos and type it out, or math.new, classify by degree, so they'll need to add text that describes this by degree, describe it by number of terms, classify by the function family. Is it linear, quadratic? Maybe it's cubic. I mean, they could do that now because they know that. If it's a degree higher than that, they may have to do some research, which I'm absolutely okay with. If they want to get a degree 4, degree 5, they can look that up and get the function family name for those as well. Create a graph of your polynomial. I don't know if you're already aware of this, but they don't even need a y equals. They can just type the polynomial all by itself, and Desmos will graph the polynomial function. I even make a suggestion in their show notes that this would be a good one to make a video about and talk about your polynomial. What is this polynomial? What makes a polynomial? They could even teach basically what they've just learned in this lesson as part of their portfolio artifact for teaching, because one of the components in their 4 C's is to teach someone else what something is, and this is a perfect example of something a student could teach other students. And so that concludes our last part of this lesson. Our next lesson is our last lesson for Term 4, and then we'll be taking our Term 4 exam. Y'all have a great day.